All right, guys. So I want to take a look at probably a too complicated example of Vex for a first go around. But I'll talk all this through. Now, I want to show you what this is doing though. So right now, if I turn this angle, I want you to notice how I'm able to spin these pieces. Okay, so if I wanted something that was a little more random and in the layout or something like that, let's like for example, sometimes if you do this, this could be very uniform, and you could spin it and get some randomness. Okay, so this can be helpful. Now the other thing I want to point out too, I also have a blend. Then I'm blending to something completely different. So if you had trees or something like that that would be standing more upright, and you want to spin those around and have some randomness, because if we put the angle here, you'll notice everything's kind of pointing in the same way. But if I go here, we have something that's each piece is rotated randomly. We also have, and I can actually make some channels for this too, but we have some random scales. So we've got a random scale where the smallest is 0.5 and the largest is 0.2. So actually we could take this and maybe make the smallest like 1.0, and we'll see some of those smaller pieces get larger. But um, again, we have a way to spin these, and then if we lay them flat, like something that would feel more like debris or rocks or something like that that follows the contour of your land or something like that, you could do that, and then this would also kind of spin and give you some stuff. So I want to talk to you. I don't think we're going to type all this code, but I do want to talk it out so you have an idea of what's going on. So first things first, and I don't want to hit math too hard, but I'm going to go over some cursory stuff, some kind of higher level stuff, so at least you know what's happening here, like so that we know what radians are, and that we know what quaternions are, and we know how to plug those in. We don't have to do the math to figure all this out, but we need to understand what to give Houdini so that it works the way that we want. So first things first, if you come to Houdini, you can actually go to Google and search Vex, and you can find all sorts of different Vex functions. One of these is a quaternion, and we'll see a few different ways that we could do this. The way that we're going to do this is right here. And so if this is the function, but we have to give the function two things, an angle and an axis. So what is a quaternion though? Let's kind of start there. So I pulled some things up um, on Wikipedia so you could look at some of these, and just to be able to kind of get your minds around this. So Cartesian coordinates. This is kind of what we are used to with like Maya and other 3D applications, that we have x coordinates, we have y coordinates, and then we have z coordinates that kind of go back and forth in 3D space, and we have numbers that represent all of that, right? That's the Cartesian coordinate system. And so we should be pretty familiar with that. Now, if we come to Euler angles, we'll see that Euler angles give us a nice way to kind of spin around certain axes, like the roll axis, the yaw, or the pitch. Okay. Now, quaternions give us a way to do that with any vector. Like, and when I say a vector, it's kind of like this arrow. So something that's pointing off in any direction. It doesn't have to be on one of these specific coordinates. It can be anywhere. It could be pointing off this anywhere. And as long as we have this vector, and we've told it how much we want it to spin. So again, if we come back here, we need to give it an angle and an axis. This arrow, this vector, is the axis. So we need to give it that vector so that we know where to spin it around. Okay. And then the angle is how much it's going to spin around. Okay. So we have to give it two things like that. And so here we've got a float. We need an angle that is a float, and we need a vector, which is pretty common for an axis. So like normals or something like that are vectors. Now, the thing is, though, we need to read down here, okay? And there's a specific line, okay, so we need to give it an angle and an axis, but the angle needs to be in radians. Oh, okay, so what are radians? Again, I pulled this up in Wikipedia, and there's a nice little graphic right here. And that's a radius. The radius is a radian. And so if we look at this radius being wrapped around, this is 1 radian. Okay? And then we can get 2 radian and 3 radian and so forth until we get like 2 pi radians, okay? Which would be equal to 360 degrees, right? So down here we've got 2 pi radians is equal to 360 degrees. Okay, but we have to convert this to radians for Houdini to be able to do that. Now, that's not hard for us to do. Houdini's going to do all the math, right? We don't need to do the math. We just need to tell Houdini that we want a certain set of float numbers, so decimal point numbers. We just want to tell Houdini that to treat that as radians, okay? So my point in showing you all this isn't necessarily for you to understand like, oh, snap, I've got to know all this math, sines and cosine. No. I just need you to understand that we can use normals or something like that has a vector as our axis. And then we can spin around that with an angle, but we have to tell Houdini to treat that float value as a radian. And again, these are radians, and that's what radians mean. So I just want you to kind of have an idea or an overall understanding of what's happening. So let's go back to Houdini. Let's build this whole thing. And we're just going to copy and paste the code. So you don't even need to understand all of it. I'll talk it through so that you have an idea. And maybe I'll do type a couple of things, but I don't want you to worry too hard about having to understand all of this right now. I just want you to know where we put code and how to get it to run. Okay, so let's come up, and I'm just going to make another geometry node. I'm going to drop that down, and I'm going to dive in. And I promise we'll go over some easier examples of Vex. Right now, I just want you to kind of get a sense of some of the cool stuff that it can do. But don't worry, I know this is a little technical, but yeah, I'll talk it through. Okay, so first thing we need, click Tab, Test Geometry. Let's go to the rubber toy. Let's drop down the rubber toy. And I want to define, kind of as we've already done before, some up primitives. So, and we're going to do that with groups. So I'm going to drop down a group. I'm going to plug this in to the incoming point. Turn this group on, and let's call it up. We've already been through a lot of this, so I'm just going to do it. So the group name is $OS. We keep it as primitives. And then we're going to come down here and turn on the keep by normals. And we want to keep by normals on the Y and turn the Z to 0. Okay, I'm going to bring down the spread angle somewhere around maybe around 30 or so. So maybe something like that. Cool. Now, I want to point something else out. If I turn on my normals, we can see that the toy already has some normals. And the normals are just coming straight off the points, actually very cleanly. So I'm going to actually want to keep that. So let's do this, because we're going to change this up, but I don't want to lose these, okay? So what I want to do is I want to drop down a point wrangle, And these are the normals. And again, if we look in the geometry spreadsheet, this is all this data. Well, I'm going to change this data, but I want to save it because as we here, let me kind of pop back over to this other guy. When we have these objects lying down and across the surface like that, that's because we're having the normals help it to do that. But I need a normal that's also coming off of these kind of in a 90-degree fashion to be able to then spin this around, right? We need that axis that points straight up and off so that we can give it an angle to spin around. So if we're using a normal to aim these to kind of wrap around the body, well, the normal's not going to work so well at that point, because then if the normals are kind of pointing this way, then it would spin kind of like this, and we don't want that to happen. We want it to spin like this. So the cool thing is we have those original normals that are pointing up, so we can use our normals to help get these situated, and then use the original normals to help spin them in the direction we want. Now, here's the other thing though. I'm going to turn this off. When we change this to this position, our normals are actually changing from wrapping around the body to pointing up. In here, I'll kind of point this out, what I mean. As I go from blend, right, this blend right here that is wrapping around the body is going to be problematic because we would spin this way, right? But we want to spin that way, but we have the original normals that we can do that. When we come here, now we have the normals pointing up and our pieces go with it, which is what we want. But now we don't want to spin it around the original normals. We want to spin it around the current normals. Okay, so we need two sets of normals so that we can control how things are spinning. Long story short. Okay, so point being is I'm going to come back to the geometry too. And I want to store this normal position as a rest position, I guess we could call it. So we're going to type v at rest is equal to at n semicolon. And so that's going to store all this data right here, but in the rest. Okay. All right, cool. So the next thing we want to do is we want to change these normals. So again, we can see that this, like this x normal 9.984143, right? We can see we've saved this data over here. So we're going to keep this. But we also want to be able to get this to wrap around the body. So there's a little trick here. And if we drop down a polyframe and we put that right underneath the point wrangle and we plug that in, the polyframe has a really nice way that allows us to wrap normals around a surface. And so I'm going to turn off the normal name and I'm going to come to this tangent and I'm going to replace that tangent with capital N for normal. And all of a sudden, boom, you can see that these normals are now wrapping around the surface of our object. And we'll talk a little bit more about the polyframe later. I'll kind of explain a little bit more, but for right now, you just need to know that it's just going to wrap around and kind of point it like the next edge, or the edge that's right next to it. Okay, cool. So now we have these normals that are doing that. And now I want to drop down a scatter. So I'm going to drop down a scatter. Plug the polyframe into the scatter, and I'm going to turn on the scatter. Now the cool thing is, when we turn on the scatter, we can see that the scatter is inheriting that normal position. So if I come back to the polyframe, and if I click on this bypass, we'll see, oh, it's inheriting the normals that were pointing straight up. But if we turn that back on, we'll see that we're now inheriting the normals that wrap around the object. So that's helpful. Okay, so next thing we want to do is we want to copy something to these points. And here, I'm going to do this real quick. You don't have to do this, but I just kind of want to make a point here. So I'm going to drop down a sphere. over here. And I'm going to turn on the sphere. And I'm going to do this. Let's drop down I'm going to drop down a point, normal, or a point wrangle. Plug that into the first position of the point wrangle. So again, we always plug into the first one. We can plug more things into these other ones, but if we're just working on one object, we don't need to. So I want to set our normal, so at in is equal to set, open parentheses, 0, 1, 0. So 0 for the x, 1 for the y, 0 for the z. So it's now going to make all these points point up. Okay? So that's one thing that we could do. Type another point wrangle. Plug that into that. Turn that on. And now I want to say at in, so our normals are equal to our position. So at p, semicolon. So now we have normals that are pointing straight out. We're pointing straight up. Okay, so we've got normals that are doing different things. Okay, cool. So let's drop down a cube. And let's make this a lot smaller. 0.005, so something pretty small. And let's do a copy 2 points. And we can see we get 2 incoming arrows, so we know we have 2 incoming red arrows, so we know we have to put something in each one. So the cool thing is if you hover over the different incoming points or red arrows, is it's going to tell you what it needs. So this says required target points to copy. Oh, okay, well, we're getting our points from the sphere. So with the normal, so I'm gonna put that there. And then here this says required geometry to copy. So we want to copy boxes all around this sphere. So that's what I'm going to do. And I'm going to turn on the eyeball. Oops, turn that off. Polygon. Oh, I made these a little too small. Let's do 0.05. They were tiny. 0.005 was pretty small. Okay, cool. So now we can see how the cubes are being copied. Okay, but what if we use these other sets of normals and we plug that into that second input? Now you see, if we change it back, these normal directions can affect the orientation of the box when it's copied to the normals or to the points. Okay, and these points are essentially these right here. Right, so if I turn this off, those are the points, right? So when we copy our boxes, it's going to copy to each one of the points that made up our sphere. But it's going to inherit the normals from the points. So I hope that makes sense. Okay, so let's continue on. I'm going to delete all this. Come back to this scatter, and so here we can see we're inheriting those normals that came from our object before. But remember, we don't want to put points all over our guy. We just want to put it on that up group that we define. So on our scatter, if we come up here, we'll see group. And if I click this, we'll see up. And so I'm going to change that to that. Now that's a lot of points. So I'm going to drop that down to like 200 points. Okay. And now what we're going to do is let's put down a tube. And on the tube, I'm going to scroll all the way up. I want to, and let me just kind of double check the way I set this up before. So on the tube, we got that set to the z-axis. Okay. Okay. Sorry about that. I just wanted to double check, just to make sure I'm kind of getting the same setup. So I'm going to set this to the z-axis. And I'm going to make this quite a bit smaller. So the radius is going to be 0.01. Let's turn this on so we can see what's going on. And then our height is going to be 0.05. And I'm going to click F, kind of zoom in on this. Now we'll see that it's kind of like a hollow tube, so I want to put in caps on that. And then the other thing I want to do is I want to bring these columns down. I'd probably, if I was doing this, I'd keep like higher divisions and higher rows so that I could do some more interesting stuff. But for now, I just want to do something simple so that we can see orientations a little easier. So I'm going to keep this kind of low so that we got a triangle so that we can see as this spins a little bit easier. Okay, and then we can change something like that. And it may be that one that we want to change, but we'll move on for now. So I'm going to do another copy 2 points. And again, first input is the geometry, second input is the points. And so I'm going to copy some points. And right off the bat, I can see just because we have kind of set these cool polyframed normals, that it's already just kind of random, right? So that's one of the big things. You don't want to just, if we turn that off, right, that's going to be pointing straight up. So actually, let's come back to that tube and let's change that radius to 0.5 there and maybe 0.2 here. Okay, and again, we could change this to be like our x-axis or a y-axis or something like that. And so if we had it something like that, you can see like, yeah, it's laying on the surface, and maybe that's cool, maybe that's what we want, but we might want something a little more randomized. So I'll do that again and put that back to Z. And so by doing it, by using our polyframe, it just gives us some nice random normals anyways, and so it just doesn't look too uniform. So if we wanted rocks scattered around, but they're kind of spun a little bit differently, this just right out of the gate just gives us something kind of fun. Okay, so the other thing I want to do is I want to merge all this. So I'm going to drop down a merge node, plug in the copy to points, and then I want to plug in the original rubber toy. So now we can see we've got some scattered debris or rocks or something like that laying just on areas that would make sense. And like if a piece was here, it would probably fall, right? Okay, so we want to make this a little more interesting though with vects. So I'm going to drop down a point wrangle, and I'm going to hover that and put that right in the middle. Okay, and so you can see as I did, I'm going to do Control Z again. You can see as I pull this into there, it wants to inherit the lines and just kind of insert itself. And so I'm going to let go and it will do that, which is really cool. So again, as I kind of mentioned before, we do have some certain attributes that are just native, right? We could create our own attributes, but we have some attributes that are just native to Houdini. One of those being the p-scale. We've already been using the normal. But I want to, let's go back to Houdini. I want to use that p-scale. And so we're going to paste the code in here in a second, but I want to kind of give you a sense of what some of this is doing. So if I type at p-scale is equal to rand at ptnum. We've talked about that before. That random function is going to give us a random number between 0 and 1 and semicolon. And so now we're going to see these pieces aren't all the same size, but there's going to be some that are like crazy tiny. So again, like we did in the last video, we might want to fit this into a fit range. So fit 0, 1, and just a reminder, for the fit 0, 1, we need a float value. So every point has now a random value between 0 and 1. And we want to remap this so that the very smallest piece, which would be basically 0, is not 0 anymore. And so, and then our new size maybe is a little bit bigger. So let's do that. So comma, and let's type 0.5. So that's as small as it can get. Comma, and then we'll type like 2.0 and close parentheses. And so now we have some pieces that are like this size, but we also have some pieces that are that size. But we don't have like these tiny little specks that are like almost zero. So that's kind of nice. Now the other thing, let's just go ahead and get rid of that. And let's paste that code. So I still believe I've got it copied. So I'm going to just do Control V as in Victor. And it's going to give us some code here. Cool. Now, one of the things that you'll notice is in here, I have this CHF. So what this means is this is a channel float, and I have an open parentheses, a quotation, and then I've named it. So something like blend, and then quotations, and then close parentheses. So what this little bit of code right here is going to do is it's going to give me a slider down here that's going to be a float, so that I can change the float value. And I've got a couple of those. So I've got another one right there. So I'm going to get, or actually that's the same one. I have another one right here that's going to give me an angle. So we're going to create a blend and an angle. And the way we do that is once we have those referenced in here, if we come over here and we click this button and we scroll down, we'll see now that we have some numbers for that. And here we can see we're blending from one position to the other. And we are able to rotate or stand those up and rotate. And this is, again, this is kind of nice because if you come in here and look, these are all kind of, when they're at this angle, they're all kind of pointing in the same direction. But if we change that angle, now we'll see that we're getting, you know, this and this are not pointing in the same angle. We're getting some randomized rotation. Now, let's do something, and I'll talk all this out a little bit, but let's do something. Let's add some more in there. So kind of like I mentioned, maybe I want this to be 1, maybe I want it to be 2, but it might be kind of nice if we had some sliders down here for those too. So let's replace this 1.0, because we could change this. Like we could put like 5, but it'd be nice to not have to come in here and tweak the code. We could just have some sliders that would do that for us. So let's do CHF, so channel float, open parentheses, quotations, and let's type this min. Quotations, close quotations, and then close parentheses. And then, so that'll be our minimum. And then let's do that again. Channel float, open parentheses, quotations, and then let's call this max. And then in quotations, and then close parentheses. Okay, cool. Now you'll notice that they're not down here because we have to click this button to always update that. So I'm going to click that button, and they seem to have gone away, and that's because, well, our scales are at 0. So now if I put this back to like 4, and this up to something kind of more, a little more reasonable, like 1 or 1.5, we'll see that here we can start to control like the size of some of this stuff right from here, which is kind of cool. Okay, so again, we have this blend. So maybe we don't want them quite that big when they're kind of laying like this. But this could be kind of cool, like if you did something where you needed debris, maybe pieces of wood scattered all the place, or rocks, or whatever the case may be, you can get some cool stuff here. And then we still also have that angle that we can spin those. Okay, so how is this all working? Let's go back and look at our points. I'm going to turn on the vectors for this. And so as I come to this blend, I want you to see what's happening. Okay, I'm blending from one to the other. And now the angle we don't see, but when they're laying down, as I mentioned, we don't want to spin them sideways. We need a vector that's pointing up and off to spin around. And that's why we created that original normal that we had up here. And we saved those as rest. Okay. And so again, we can see that right there is we're calling that. So let's look at this real quick. So one thing, and I don't recall if I mentioned this in the last video or not, But if you put these 2 forward slashes, that means you're creating a commented section. So that means if you put those 2 slashes, this line of code will not be run. But this is great because this allows you to type in plain English what you're doing. And that makes a lot more sense when you come back and look at this, or you hand it off to somebody. They can see like, oh, this little bit of code is doing this. Oh, these 2 lines of code are doing this, and so forth. So a second ago, we already talked about the p-scale and fitting and doing the random at pt_num and then doing a fit a 1. And then in this case, we created a couple channels that we could control the minimum and the maximum, right? So instead of 0 to 1 randomly across points, now we have it random sized. Of the smallest it can be is 1.7, and the biggest it can be is 3.3. Okay, so when I typed this out originally, I think that was the first thing I typed. Okay, now the other thing I needed to do, and you'll notice that I've got some @in, but I've also got some of these, as I mentioned earlier, local variables. So here I wanted to set an up vector, right? And so that we could call that, do that, so that we have an up vector. And so we can see that we're creating an up vector. Now our normal hasn't been assigned to that yet, but this vector exists. Okay. So this is setting a normal up that we could blend with the current normal. Okay. This next line, so we want to blend from one normal to another. Also blend the rotation axis. So what we've done here is we've got our normal, and I've got it set to this function. I haven't shown you guys yet, but I'll try to show that to you and we can build one together. But this is a linear interpolation. And what that means is it's a blend. Linear interpolation is a blend. And you have to give it 3 things. You have to give it the first vector, and then a second vector, and then you blend back and forth. So what that means is down here is when it's at 0, it is this vector. When it's at 1, it's this vector. And when it's at like 0.5, that would be gray, right? Like if you're blending from white to black, the 0.5 would be like gray, like you're going from one to the other, but you're not completely one or the other, you're somewhere in between. So you can use lerps for all sorts of cool stuff. And so the blend is being controlled by this right here. Okay. In this case, we kind of really want one or the other, but in other effects, it's kind of cool when you can kind of get something that is in between. Okay, so this is controlling our normal. So what we see right here, this blend, where we're seeing the normals actually change, that is that line of code. Now this other line of code, this vector axis, that's also using a lerp between our normal and then our original normal, also using the blend, this is running invisible. And what that's saying is when it's laying down like this, use the original normal, so the rest. And when it's pointing up, go ahead and use the normal. So when it's pointing up, it's saying go ahead and spin around the normal. But when it's at 1, okay, so when our blend is at 1, it's saying, okay, don't spin around the normal anymore. Okay, this one is changing the normal, but this one is more about the spin. And so this is saying don't spin around the normal anymore. Spin around the old normal, which was pointing like this. And so now our pieces will spin in a direction like this. Okay. We already talked about our p-scale. And then down here, this is where we get into setting the quaternion. So when I showed you that quaternion expression right here, that's just that. You know, this is just that. Quaternion angle axis. And so that's why I specifically named these vectors that I created. Where's the angle? Right here. That's why I called this, all this stuff that I did, I called it angle, right? So I was just generating a random point number and then refitting it between 0 and 360, right? So again, the angle, we want to spin it not just randomly around 0 to 1, that wouldn't spin very far. We wanted to refit that to a full sweep of 0 to 360. And so we defined that angle here, and so we're calling it there. But if you remember, we need to turn that to radians. And then this axis is where we're telling things to spin around. And so that's what that quaternion is doing. And so this axis updates where it's spinning based off of where things are blending. So I kind of talked that out. So like I said, I know this is a little more technical, and if none of that made sense to you, that's okay. This is a kind of deeper dive into setting using math and things like that. And so it's probably a little too technical to throw at you guys this early. Um, so so don't worry about it, right? I don't really intend, especially if this is the first time you've ever worked with Vex or something like that. I don't know that I would feel like, okay, well, you just saw how to do all this stuff. You can type code like that. Now you'll start at a little bit of a lower rate as you're learning and doing some basic stuff like doing random app PT and fitting it and maybe getting some random scales and things like that. But I also want you to know how to take code. So if you find code that somebody online has put out there and you're like, oh, and they say that this does this, and you're like, oh snap, that's really cool, I want to use it. I don't understand what it's saying, but I want to use it. You can copy it, come in here and paste it, and then just click this button and you'll get like these types of controls. So I want you to be able to know how to do that too. Okay, so like I said, don't worry if you don't understand all this. We're going to go over some simpler versions of the code. Um, but yeah, I just wanted to give you an idea over how this can do some pretty cool stuff. Another thing I'll mention, if there is a node that I have things like this on there that I can change stuff on, sometimes I like to color code this. So I'm going to click C, or you can come up here and click this. And I just want to drag green out to that. So that's just for me. You could come up with your own color code system, but I know if I see a node that's green in here, there's something in here that I can tweak. And by the way, we could also do that with the scatter, so I could maybe even color that green. And the reason why I'm doing that is if I come to the scatter, well, I could change the number of stuff, but I could also change, there's down here a random seed. And so if I change this seed, it's going to, what it's doing is it's just changing out where the points are laid. It's just kind of randomly relaying them at different places. And so that can give us some nice different layout. And so here you could play with all sorts of fun stuff. So if we come back to here and we come back to the scatter, let's see, want to increase that total count. We can do some fun stuff like that. So there's all sorts of cool stuff we could do. We could come up with some different blends. So even if you were trying to make like some geometric hair, you could probably even do that here. So maybe we could have this as like a 0.1 or something like that. So you could, there could be even maybe 0.01. So you could even come up with some fun things and maybe even bend this a little bit more. But you could come up, I mean, you could use this for like a gazillion different things, sticking some of that out. Not that I would like design hair like this, but if you're going for something stylized, maybe, So anyway, I just wanted to kind of cover some of this and show you some kind of fun, cool stuff that you could do. So yeah, even like right there, if we were trying to do some hair, we could kind of mess it up a little bit. So make rocks, make hair, make trees. Yeah, so this little bit of code would give you kind of some flexibility on randomizing scale of objects, randomizing rotation, randomizing whether it's laying flat across the surface or standing up. This little bit of code will give you So flexibility on to control different things, regardless of what you're trying to do. So if you want things standing up, like hair, trees, whatever, you can do some fun stuff like that, or you can scatter rocks and um, whatever. So pieces of wood, debris, or something like that. So this kind of creates some flexibility to do either or. So anyways, hopefully this has been helpful. Feel free to ask questions if you want me to kind of explain this again. I'll try to talk it through a little bit as well in class, but yeah, hopefully this has been helpful.